All right, so I want to quickly complete this solution that we're trying to solve during the live session today. It says, find the coefficient of the third term in the expansion of 2x plus y to the power of 10 using the binomial theorem. So remember that I said the binomial theorem is given by if you have a binomial term, a plus b to the power of n, this can be expanded as a summation. Sorry. So why is it not cleaning? Summation. Okay. So why is my pen not cleaning off? All right. So I was doing the wrong thing. Summation n combination r, a to the power of n minus r, b raised to the power r, where r starts from 0 to n. So the third term, right, will be when r equals 2. Now remember that r starts from 0, so you have r equals 1, 0, that is the first term, r equals 1, that will be the second term, and r equals 2 will be the third term. So the third term will be when r equals 2. Now you work with only that term in the expansion 2x plus y to the power of 10. That becomes the summation of 10, because n is 10, from r equals, okay, we're dealing with the term r equals 2, so it's not going to be summation anymore. We're not going to work with submission, we're dealing with just that single term, the third term. So the third term will be without the submission sign, 10 combination 2, because we're working with the term when r equals 2, 2x, because here a is in place of 2x, we pick 2x, and then b is going to be y, substitute uh, a with 2x and substitute b with y. So 2x all to the power of, put all the 2x, the term in the bracket, all to the power of 10 minus 2, and y to the power of what? 2. All right, let's simplify this further. So this will give 10 combination 2 times 2 to the 2x to the power of 8 times y to the power of 2. All right. Now, what is 10 combination 2? You can actually evaluate this with your calculator. All right. Or you can also use the formula n combination r, which is equal to n factorial over r factorial times n minus r factorial, which means 10 combination 2 is equal to 10 factorial over 2 factorial times 10 minus 2 factorial, which is 10 factorial over 2 factorial, 8 factorial. And that is nothing but 10 times 9 times 8 factorial over 2 factorial, 8 factorial. 8 factorial cancels out 8 factorial. 2 factorial is 2, which is 2 times 1. And 2 in 10 is 5. So 5 times 9 is 45. So which means that 10 combination 2 is 45. So this is going to be 45 times 2 to the power of 8. When you open the bracket, x to the power of 8 and y to the power of 2. Okay? Excuse me. I wrote 8 to the power of 8 instead of 2 to the power of 8. So at this point, you will need to pick your calculator and evaluate 2 to the power of 8. So let me evaluate 2 to the power of 8 with my calculator. This becomes 45. So where's my calculator? Let me open my scientific calculator on my phone. Do I have one? Oh, I think I have not installed scientific calculator on this phone. So I believe you have your. Let me see if I can go to the scientific mode. So I'm trying to see if I can change the mode of my calculator. Where is my? Okay. No, this is not what I'm looking for. Sorry about this. Okay. Let me see if this is it. No, this is not it. Okay, here I found it here. Yeah, I've seen what I'm looking for. So 2 to the power of 8, that is 2 to the power of 8 gives 2. So this 45 times 2, 5, 6 times x to the power of 8 and y to the power of 2. All right. Now multiply 256 by 45. That will give 11,520 times x to the power of 8 times y to the power of 2. Therefore, the coefficient of the third term, the coefficient of the third term in the binomial expansion, the coefficient of the third term in the binomial expansion is 11,520. So that's the answer to this question. That's the answer to the question. I hope you understand how I solved this. All right, so I have like two more questions which I would like us to look at again. This very one says expand x plus 2 to the power of 4 and find the coefficient of x squared. Okay, there are two instructions here. We need to expand this and then we need to find the coefficient. So I would solve this question by expanding and also by solving, or before I expand. So because it's an objective question, you wouldn't find any, I mean, your forthcoming exams will all be objective, so you wouldn't find any question that says expand. So let me first of all find the coefficient of x squared. All right, assuming that is the question. Because say in the binomial expansion of x plus 2 to the power of 4, what's the coefficient of x squared? Okay, so if that's the question, you always have to remember the formula a plus b to the power of n, which is the summation of n combination r times a to the power of n minus r times b to the power of r, where r starts from 0 to n. Okay, so the coefficient of x squared, to calculate the coefficient of x squared, it will be the term, right, where, so because x is the first term right here, which means x is equivalent to a in the expansion formula. When you compare x plus 2 with a plus b, x is equivalent to a, right? So it means that for x squared, is going to be at the point where a to the power of n minus r is going to equal to x squared. So I can actually change that a to x, right? So it will be the term where x raised by n minus r will be equal to x squared. Now, by your indices, law of indices, or comparing the powers, since the bases are equal, or since the base is equal, compare the powers. So this simply means that n minus r is equal to 2. Okay, so it will be at the point, and don't forget the n is what? N is 4, right? So that is going to be 4 minus r equals 2. So it will be the point where r is equal to 2, because bringing 2 to the left, so 4 minus 2, bringing r to the right becomes r equals 4 minus 2, which is 2. So the coefficient of x squared will be at the point, or will be the position where r equals 2. That will be the coefficient of x. I mean, that's going to give us the term that has x squared, of which you can actually calculate the coefficient. So let's solve for when r equals 2, and we'll go ahead and do the normal expansion and see if the answer we've obtained is actually accurate. So for r equals 2, we obtain 4 combination 2, right, times x raised to power 4 minus 2 times b, or b is 2 here, times b raised to power 2. Okay, so with this we have 4 combination 2 times x raised to power 2 times 4, right? Times 4. And 4 combination 2 is when you evaluate 4 combination 2 here. So 4 combination 2, by the formula we've seen in the previous slide, that is going to be 4 factorial over 2 factorial times 4 minus 2 factorial. And this gives 4 factorial over 2 factorial 2 factorial, which is 4 times 3 times 2 factorial over 2 factorial 2 factorial. 2 factorial cancels 2 factorial. 2 factorial in 4 is 2. 2 times 4 is 6. I mean, 2 times 3 is 6 rather. So this is going to be 6x raised to power 4 times 4. I mean, it's raised to power 2 times 4. And 4 times 6 is 24. X raised to power 2. So which means that the coefficient of x squared is 24. Therefore, the coefficient of x squared is 24. So do you see how I solved this? Now let's assume that I want to go ahead with the expansion of x plus 2 to the power of 4. right? Because that's what this particular question says. It says expand this and obtain the coefficient. But I just went through the route of obtaining the coefficient because this is the type of questions you will see. You will not be required to perform any expansion. So let's go ahead and expand that polynomial, and then we'll compare the answer for the coefficient of x squared upon expansion. We see if we obtain the answer as we've gotten here, which is 24. So by expansion, x plus 2 to the power of 4, all right, using the formula, this is going to be 4 combination 0, start from 0, x raised to the power 4 minus 0 times 2 raised to the power 0 plus 4 combination 1, x raised to the power 4 minus 1 times 2 raised to the power 1 plus 4 combination 2, you have x raised to the power 4 minus 2 times 2 raised to the power 2. Then, let me continue here. Plus 4 combination 3. I have x raised to the power 4 minus 3 times 2 raised to the power 3. Plus 4 combination 4. X raised to the power 4 minus 4 times 2 raised to the power 4. Alright, so 4 combination 0, you can actually punch these values with your calculator. If you have a scientific calculator, can evaluate the values of all the combinations. So 4 combination 0 is 1. In fact, n combination 0 is always equal to 1. So you can check that out whenever you have time. All right, so 4 combination 0 is 1, and x raised to the power 4 minus 0 is 4, 2 raised to the power 0 is 1. So we have the first term, x raised to the power 4. 4 combination 1. 4 combination 1 is 4 plus, excuse me. So 4 combination 1 will give 4, right? And then this is 4 times 2 times x raised to the power 3. All right, because 2 raised to the power 1 is 2. So my dots here represent times. Plus 4 combination 2 is 6. We've seen that earlier. 6 times x raised to the power 2 times 2 raised to the power 2. Then plus 4 combination 3 is 4. 4x raised to the power 1 times 2 raised to the power 3. Plus 4 combination 4 is also 1. That is x raised to the power 0 times 2 raised to the power 4. All right, so when you simplify this further, we have x raised to the power 4 plus 8x raised to the power 3 plus 24, because 2 raised to the power 2 is 4. 4 times 6 is 24. 24x raised to the power 2 plus this is 8, that is 32 x plus 16. All right, so that's the answer. And when you check this out, you see that the coefficient of x squared is still 24 as seen earlier. So if you want to completely solve the question as presented, you would have to expand the binomial expression first. After expanding it, they can obtain the value of x squared, I mean the coefficient of x squared. But without expanding, this is how to solve for the coefficient of x squared as shown above. In fact, this is what you should expect more in your examination, given that it's a objective or multiple choice exams. All right, and let me take the last one. The last one says, find the coefficient of x raised to the power 5 in the expansion of 3x. Okay, I know this the expansion is cut off. So the expansion is, the binomial term is 3x minus 2 to the power of 7. This is the expansion. All right, so we want to find the coefficient of x squared. Let's recall the formula again. A plus b to the power of n is nothing but the summation of n combination r of a to the power of n minus r and b to the power of r, where r starts from 0 to 1. So at the coefficient of x squared, remember what we do? We are going to compare a to the power of n minus r to be equal to a raised to the power 5. All right, so since we are dealing with x to the power of 5, and the term x is found is in the first term, that is 3x. 3x is found in the first term. So we take 3x as a. That means we take a as 3x because it will take the position of what? A in the expansion. All right, so we'll plug in, whenever you see a, you put 3x. Whenever you see n, you put what? 7. And whenever you see what else? Okay, that's all. We want to solve for the value of r. So we're trying to get the position of that term of the binomial expansion that will suit for the coefficient of x to the power of 5. All right, so that's going to give us what? So that will be 3x to the power of n is 7, right? 3x power of 7 minus r equal to 3x to the power of 5. Okay, so opening these brackets, this will give us 3 to the power of 7 minus r, and x to the power of 7 minus r also, which is 3 to the power of 5 and x to the power of 5. Since we are interested in x and not 3, I can actually we can actually ignore this constant and work with the variable. That is x to the power of 7 minus r equals x to the power of 5. This implies that 7 minus r is equal to 5 and r should be equal to 2. So it's at the point where r equals 2 that will give us the coefficient of x to the power of 5. Excuse me. So let's plug in this in the formula and obtain the value. Okay, so it means we are going to be dealing with 7 combination 2. We are dealing with 7 combination 2, right? Times 3x to the power of 7 minus 2 times minus 2 to the power of what? 2. Because the b here is minus 2. Can you see that? The value of b we're taking as minus 2. So this is the expression, or this is the expression we have to simplify. So that is going to be 7 combination 2, yep, times 3x raised to power 5, or raised to power 5, times 4, because minus 2 raised to power 2 is 4. Okay, let's quickly evaluate 7 combination 2. So 7 combination 2 is nothing but 7 factorial over 2 factorial times 7 minus 2 factorial. And that is 7 times 6 times 5 factorial over 2 factorial 5 factorial. So 5 factorial cancel 5 factorial, 2 factorial goes into 6 3 times, and 7 times 3 is 21. So it means this is 21 times 3 to the power of 5 times x to the power of 5 times 4. All right, so this time around we have to multiply 3 to the power of 5 by 21 and 4. So let's you pick a calculator to confirm that value. So 3 to the power of 5 is multiplying 3 5 times. That is going to give us 243. Multiply 243 by 21 and multiply that value by 4. That should give about 20,412. So x to the power of 5. Can you see now? We've obtained the value, the coefficient of x to the power of 5. So the answer here is nothing but 20,400, 20,412. So this is the coefficient of x to the power of 5. So I believe with these 3 examples that we've solved in this particular video, this should help you understand, or this should help you evaluate the coefficient of any term in a binomial expansion. Please remember to like, share, and follow me in my YouTube channel if you want to see more videos like this mathematics video. Thank you very much, and I'll see you again in the next one. Bye bye.